Good morning, children. Welcome to today's session. Children, in our last class, we were studied about the write functions, how to write data into a file. Okay, so today let us learn some more functions, that is the flush function and how to remove the white spaces and blank lines from the reader data, then the significance of file pointer, then at last standard input and output and error streams. Okay, these all topics we can cover in today's section. So the first one is flush function. See, when you write onto a file using any of the write function, then the Python holds everything you are going to write into the file buffer and pushes it onto actual file on storage device later. Okay, whatever you are going to write into the file, that everything will be stored in the file buffer. After that, it will push into the disk file. Okay, so the flush function forces the writing of data on disk still pending in output buffer. Whatever it is pending in output buffer, that will be forced to write onto the disk. That is the use of flush function. The Python automatically flushes the file buffer when closing them. That is, this function is implicitly called by the close function. But if you want to flush the data before closing any file, then you can use the syntax fileObject.flush. So when you read this flush function, it will force to write the data into the disk. Now I explain this concept by using a program. See here, f is equal to open sample.txt w plus. Then f dot write, the output is /n. Then f dot write, my work status is. Then f dot flush. Here we are calling this f dot flush function. With this statement, the strings returned so far. That is, the output is and my work status is. These are the two statements we need to write into the file. So these two statements have been pushed on to actual file on disk. Okay, see the next statement, s equal to ok, f dot write of s, f dot write of /n, then f dot write finally over. These write statement strings may still be pending to be written onto the disk. Okay, these statements are pending in the output buffer. Then f dot flush. The flush function ensures that whatever is held in output buffer is written onto the actual file on disk. Okay. The next one, how to remove these blank lines or the white spaces from our reader data. See, removing white spaces after reading from file. So strict function removes the given character from both ends. Mainly three types of functions we are used to remove these white spaces from the reader data. First one is strip, second one is rstrip, and third one is lstrip. Okay, see children, when we use this read function or readline functions, then the data, when we use the read function, data we read from the file and return it in string form. And the readline function returns the entire file content in a list where each line is one item of the list. Then all these read functions also read the leading and trailing white spaces, that is, spaces or tabs or no line characters. If you want to remove any of these spaces, then you can use this strip, rstrip and lstrip. Okay, first one is strip. The strip function removes the given character from both ends. Okay, then rstrip, it removes the given character from trailing end. Trailing end means right end. Then next one, lstrip. Lstrip. Lstrip removes the given character from leading end, that is left end. So these are the three functions, strip, rstrip and lstrip. Strip remove character from both ends. Rstrip remove character from right end and else strip remove characters from the left end. Which character you want to remove? Okay, that you have to specify that character should remove from the left end. See the example. First one, removing EOL, that is slash n character from the line. Read from the file. Okay, so fh is the file handle or the file object. Fh is equal to open sample.txt r mode. Then line is equal to fh dot read line. Line is equal to line dot rstrip slash n. See this rstrip slash n, it will remove the end of line, that is the new line character slash n from the reader line. So when you use this length of line, len function is used to find the length of line. So when you use this len of line, it will give the length after removing this slash n character. Next one, removing leading white spaces from the line. Read from the file. Here line is equal to open sample.txt r.read line. So first it open the file, then read line will read first line. Okay, then line is equal to line.lstrip. Okay, then next, so these are the different functions: strip, lstrip and rstrip. Rstrip remove characters, given characters from the right side, and lstrip remove the given characters from the left side. Next one, the significance of file pointer in file handling. Children, every file maintains a file pointer. Every file maintains a file pointer which tells the current position in the file where writing or reading will take place. Okay, that is when you open a file, there is a file pointer that will point to the first location. Then whenever you read something from the file or writing onto a file, then this operation takes place at the position of file pointer, and the file pointer advances by the specified number of bytes. Okay, how many bytes you read, that much bytes will be added with the file pointer, and the file pointer will move to the next byte. That's why file pointer advances by the specified number of bytes. Okay, for example, see when we read a function, that is fh is equal to open marks.dat r mode. Okay, when you open a file, initially the file pointer will point to the first location, that is the first position. For example, the data is high, high. Okay, then the file pointer will be point to h. Okay, then when you use this instruction, ch is equal to fh dot read 1. Okay, fh dot read 1 means it will read first character h. Okay, initially the file pointer points to first character. Then when you read the first character by using a read function, it will read the first character and the file pointer will move to next position. Then when you read second character by using the read function, it will read second character, then it will move to next character, that is third one. That is, the file pointer advances by the specified number of bytes. The different modes and the opening position of file pointer. See R, RB, R plus, RB plus and R plus. Okay, these all are for read function with the text file and binary file. Okay, B for binary, then this plus means read and write. See, when you use R, RB, R plus, RB plus and R plus, then the file pointer will be the beginning of the file. File pointer pointing at the beginning of the file. When you use W, WB, W plus, WB plus, W plus, W plus B. Okay, when you use this type of mode, then the file pointer will pointing to the beginning of the file. It will overwrite the file if the file exists. Okay, it is a writing function. So if the file is exists, then it will overwrite the file, otherwise it will pointing to the beginning of the file. Then A for append, AB, A plus, AB plus and A plus B. This one pointing at the end of the file if the file exists, otherwise creates a new file. Okay, next one, standard input output and error streams. See children, we have one standard input device, that one is keyboard, and our standard output device is monitor. That is, you can read data from the keyboard and you can give output to the, that is, keyboard is the standard input device and the monitor is the standard output device. Similarly, if any error is occurs, it will be also displayed on the monitor. So the monitor is also called standard error device. Okay, then we have standard input device, that is STDIM. STDIM, it reads from the keyboard. Standard output device STD out. Okay, it prints to the display and can be redirected as standard input. Then standard error device STDERR. It is same as standard out STD out, but normally only for errors. Okay, having error output separately allows the user to divert regular output to a file and still be able to read error messages. Okay, so to use these functions, standard stdin, stdout, stderr, first we need to import one module called sys module. Okay, if you import this sys module in your program, then you can use sys.stdin.read. Okay, this function you can use to read from keyboard. sys.stdout.write. This function you can use to write onto the monitor. Okay, that is sys.stdin.read is used to read from the keyboard. And this function stdout.write is used to write the data onto the monitor. See, sys.stdin and sys.stdout are like files which are opened by the Python when you start Python. Okay, the sys.stdin is always open in read mode. Clear? Sys.stdin is always opened in read mode because it is a standard input device. That's why it is always open in read mode, and sys.output is always open in write mode. Okay, see the example, fh import sys, fh is equal to open or sample.txt, line 1 is equal to fh.readline, line 2 is equal to fh.readline, sys.stdout.write line 1, sys.stdout.write line 2, sys.stderr.write no errors occurred. Okay, see here we are writing this line 1. Okay, first we read 2 lines from our text, our file sample.txt. Then the reader lines we write into the monitor without using any print statement. Now let us check the output. Then when you use that program, then you will get the output as, the output is my work status is okay. Then it is also printed the error message, no errors occurred. Clear? So these are the input, output and error stream. So to use these functions, first we need to import the module, sys module. Okay, so now I believe you all understood all the topics that I am covering today. Anyone have any doubt, please note down in your notebook, then clear your doubts in the live section. Okay, see you again with another topic. Till then, bye. Thank you.